In this video, you will learn to recognize problems without solutions. And I'm going to walk you through 3 different examples, each of which will have no solution. The first one, we are dealing with a girl named Beth, and it says for her first 2 hours of her trip, she drove at her normal speed. But then an accident forced her to drive 10 miles per hour slower than her normal speed. Still, she made the trip in 3 hours. Find the normal speed. So this is a distance problem. We have rate and time. So we can do our table here where you have rate times time equals distance. And then you have the first part of the trip and then the rest of the trip. So her rate for the first part is her normal speed. So that would be r. And then the time she traveled at that speed was 2 hours. So her distance is rate times time, or r times 2, which is 2 times r, or 2r. And then the rest of her trip, her speed was 10 miles per hour slower. So you take her regular rate and subtract 10. So it's rate minus 10 miles per hour. And the time she traveled at that speed is 1 hour. So her distance, you would take rate times time. So r minus 10 times 1, which would still be r minus 10. Now this one does not have a solution because you don't have enough information to actually solve this. So if we knew something about the distance, like the first part of the trip was the same distance as the second part of the trip, or the total distance was, maybe 40 miles, then you can set up an equation. But our equation, we need to look at this last column, and with the distance, there's nothing given in the problem to set up an equation. So this one would have no solution. Example 2. We have a lawn that is 8 yards longer than it is wide. It is surrounded by a flower bed 5 yards wide. Find the dimensions of the lawn if the area of the flower bed is 140 square yards. So to begin with, we can draw a picture. In the middle we have the lawn, on the outside we have the flower bed. We're trying to find the dimensions of the lawn. So the width we don't know, we'll call that x. And then the length is going to be 8 yards longer, so x plus 8 would be the length of the lawn. And then we know that the width of the flower bed is 5 yards. So from here to here is 5 yards, and from here to here is 5 yards. So from here, we need to set up an equation. So we know that the area of the entire yard would include the area of the lawn plus the area of this flower bed on the outside. If I add those together, I get the area of the entire yard. So that is my equation. Area of the entire yard equals the area of the lawn plus area of the flower bed. So the area of the lawn is a rectangle, and the area of a rectangle is length times width. So the width is x, the length is x plus 8. So the area, you take length times width, which will give you x times x plus 8. And then for the entire yard, the width of the entire yard, you take the x right here, and then you have to add 5 for this part, and then 5 for this part. So 5 plus 5 is 10. Add that with the x right here, that gives me 10 plus x, or x plus 10 for the width. Same thing for the length of the entire yard. The length of the lawn is x plus 8. We add that with the 5 to get to here, plus another 5 to get over here. We have x plus 8 plus 10, which would be x plus 18. And the area is length times width of a rectangle. So if we take x plus 10 times x plus 18, that gives me the area of the lawn. So now putting it all together, the area of the entire yard, or the area of the lawn, is x plus 10 times x plus 18. that is equal to the area of the lawn, which was x times x plus 8, which is right here, plus the area of the flower bed, which is given to us as 140, so plus 140. So from here we can solve. To begin with, we distribute the x and the plus 10 to both x and 18 over here. So we have x times x and x times 18. That gives me x squared plus 18x. And then 10 times x plus 10 times 18 would give me 10x plus 180. And then over here, we distribute the x to get x times x, which is x squared, plus 8 times x, which is 8x, and then plus the 140. Now we can simplify. 18x plus 10x would give me 28x. And then I can bring the x squareds to the same side. So I can subtract x squared over here to bring it to the left. So I subtract over here as well. When I do that, the x squareds cancel on both sides. So I have 28x plus 180 equals 8x plus 140. Now I need to bring the x's together. So I bring the 8x over to the left by subtracting. So I'll subtract 8x from both sides. When I do that, on the left I have 20x, and then the plus 180. And on the right I have 140. I can bring the 180 over to the right side by subtracting. So I subtract 180. And when I do that, I now have 20x on the left, and then I have negative 140 on the right. And then divide both sides by 20. Now I have x on the left and negative 7 on the right. So here, all of this was to show you that we have an answer that is negative. And in this case, x is our width, and width cannot be negative. So therefore, this problem would have no solution because there's no such thing as a negative width. Now for our third example, and this one also has no solution. And here is why. So we're given that Terry says he has an equal number of dimes and quarters and 3 times as many nickels as dimes. The value of his nickels and dimes is 50 cents more than the value of his quarters. How many of each kind of coin does he have? So he has an equal number of dimes and quarters. So if we let dimes be x, that's the number of dimes, then the number of quarters would also be x, because those are the same. And then the nickels, there are 3 times as many nickels. So the nickels would be 3 times x. So now looking at the value, because that is what is also given, talks about the value of his coins. The value of the dimes we find by taking 10 cents times the number of dimes he has. So we have 10 times x would be his value for his dimes. For his quarters, each quarter is 25 cents. So the value of his quarters is 25 cents times the number of quarters that he has. So that would be 25 times x. And then his nickels are worth 5 cents. So 5 cents times this number of nickels. So 5 cents times 3 times x. Okay, so from here we can set up our equation. We are told that the value of his nickels and dimes is 50 cents more than the value of his quarters. So if I take the value of his nickels plus the value of his dimes, that is equal to the value of his quarters plus 50 cents. Because over on the left side, this is 50 cents more than the value of his quarters. So I need to add 50 on this side to make sure that it balances out. So this is my equation. And I could plug in the different values. So value of nickels was 5 times 3x, which is 15x. Value of dimes is 10x. So we have 15x plus 10x equals value of his quarters, which is 25x, and then plus 50. So from here I can solve. 15x plus 10x is 25x. And then I bring the 25x to the same side. I can subtract to bring it over. When I subtract, the 25x's cancel on both sides. So on the left side, I'm left with 0, and on the right side, I'm left with 50. So this is not a true statement. The variables are gone, which is kind of unusual, and this is a false statement. 0 is not equal to 50. So when you see that, where you have a statement without variables left in there, and it's false, this would have no solution as well. Alright, so we've shown 3 different examples, all of which have no solution. The first one, there was not enough information given. The second one, we had a negative number when we were dealing with answers that should only be positive, or the width was negative, which doesn't make sense. And then this third example, when we solve, we get this weird thing at the end where it's a false statement with no variables left over. So that as well would be no solution. So if you see any of those 3 things, you can know that there would be no solution to those problems. And that concludes our lesson for today. We will see you next time.